I welcome class 8 students to this chemistry chapter. This is class 8, subject is chemistry, and the title of chapter is atomic structure. Students, we have completed session 1. Let us start session 2, and we will start this session with the discovery of neutrons. So please follow the mouse cursor. I am painting the mouse cursor in yellow color. The mass of an atom was in fact considered to be entirely concentrated within the nucleus, but the mass of proton was greater and mass of electron was very less. So scientists have ignored the mass of electron. Now, after the experiment, they realized that total mass of atom was far more different from the total mass of present protons in the atom. So they realized that the atom should contain something more than just electron and proton. After the experimentation in 1932, James Chadwick discovered this unknown particle and called it a neutron. It was called a neutron because it has no charge. Its mass was found to be equal to the mass of proton, that is 1.672 into 10 to the power minus 24 gram. Students, let us see the three basic properties of a neutron. First property, mass of neutron is slightly more than that of proton. You can see slightly more. Now 1.676 is of neutron and 1.672 of proton. Second property, electrically a neutron is neutral. It means it has no charge, no plus charge, no minus charge. Third, atoms of same element may differ in number of neutrons, leading to the formation of isotopes. Students, please pay attention to this table. We are checking this table 3.1, and here we can see the properties of subatomic particles. If you are paying close attention, you can see the symbol, the charge and the atomic mass are given in the box. An atom of hydrogen contains only the proton and one electron, but no neutron. All other atoms have three particles present. Students, let us see the structural stability of an atom. We know that there exists a force of attraction between the particle with opposite electrical charges. Thus, there is a force of attraction between the electrons and proton present in the atom. It means proton attracts the electron. Now, it is expected that electron being lighter and in constant motion would gradually lose energy and come closer to the nucleus and eventually fall into the nucleus. Let us see the figure. Here proton is present and this is electron, and after revolving, electron will revolve and its orbit radius will be going to smaller, and one time this electron will come in contact with this proton. Now, students, can you imagine what will happen if electron comes in contact of this proton? That will be a very disastrous condition. Why? Because proton has plus charge and electron has minus charge. When plus and minus meet, they will cancel each other and atom will die. This was Rutherford atomic model, but since atom was going to die, this model was discarded. This model was modified by Niels Bohr, who could explain the atomic stability in a better sense. Now let us see the Bohr theory. According to Bohr theory, the electron revolves in a fixed orbit or cell around the nucleus with very high speed, and each orbit is associated with a certain amount of energy. Students, compare the figure which we have seen on last page and figure on this page. You can see on the previous page the radius was decreasing, but in this case they are actually concentric circles. So the radius is not increasing or radius is not decreasing. Thus they maintain their position. As a result, inward force exerted by the nucleus is counterbalanced by the outer force of moving neutron. Hence, atom will not die. So this was actually Niels Bohr theory. We will see the modern model of atom. Now, modern model of atom has 5 basic points and we will see all the 5 points in detail. First point, an atom consists of subatomic particles called electron, proton and neutron. Second point, there are 2 structural parts of atom. First is inner part is nucleus. Nucleus means center. Second is the orbit or shell. What is orbit and what is shell? They are extranuclear part, circular in shape, in which atoms electron revolve. Third point, the nucleus is positively charged central part of an atom. It consists of protons and neutrons. The proton and neutrons are called nucleons. You can see here nucleon. They are held firmly in the nucleus by a strong nuclear force. The entire mass of atom lies in its nucleus, since atom's electron has a very less mass. Now, the positive charge of nucleus is due to proton and the negative charge of atom is due to the electron. We will see fourth point. Fourth point, the orbit are imaginary path. It means they are only exist in our theory, and they are traced by electrons in empty space surrounding the nucleus. Each orbit is associated with fixed amount of energy, and these orbits are also called energy level or energy cell. Electrons revolve around the nucleus in these orbits. The cell lying very close to nucleus, having very lowest amount of energy, and the cell which is very far distant has maximum energy. Point number 5. An atom is electrically neutral because number of positive charge by proton is equal to number of negative charge by electron. So, number of plus equals number of minus equals no charge. While the neutron is present there, but neutron do not contribute anything to the charge. Neutron only contribute towards the mass. While the neutral atom of an atom element has an equal number of proton and electron, this number itself varies from one element to other element. So, if the number of neutrons is different, then we can say that there exists some isotopes. The electrons, protons and neutrons are only 3 names. If you go to class 11 and 12, you will study about 10 more particles, and scientists have discovered 200 subatomic particles till date. So students, till class 10 you are concerned with only 3. In class 11, 12 you are concerned with 12 or 13. But in later state, if you study engineering or do research, you will learn about 50 more particles. Next point in our discussion is atomic number. Symbol of atomic number is Z. And what is atomic number? Atomic number is number of protons present in an atom. You can see here the definition is also given. What is atomic number? Atomic number is equal to the number of proton, or atomic number is equal to the number of electrons. For example, if an atom of oxygen contains 8 protons, therefore its atomic number will be 8. In its neutral atom, the number of electrons will be also 8. Students, please pay attention to this theory. Atomic number is equal to the number of protons is equal to number of electrons in neutral state. Next point in our discussion is mass number. What is mass number? Sum of number of protons plus number of neutrons. Students, please follow the mouse cursor. Mass number is equal to number of protons plus number of neutrons. So, if you add up the number of protons and the neutrons, you will get the mass number. Now, here are calculations. How will you find the number of neutrons present in an atom? Then we have to subtract. It means minus. Atomic number is subtracted from mass number and the result will be the number of neutrons. Let us see one example for this. Suppose we have a sodium atom. This is sodium atom. Its atomic number is 11 and mass number is 23. So, if 23 is subtracted from 11, we will get 12. And this 12 is the number of neutrons present in sodium atom. Symbolic representation of an element with atomic number and mass number. It means how an atom is represented in terms of atomic number and mass number. Students, please follow the mouse cursor. Look at the place I am highlighting. Suppose this is a example. This X is an element. You can see upper side A is mass number and lower side Z is atomic number. You can write this as also in this format also. Students, follow this format because this is very easy. X is element, upper A is mass number and lower Z is atomic number. Let us conceptualize with this an example. Suppose this is an example. We have O. O means oxygen atom. You can see 16. 16 is mass number. You can see 8. 8 is atomic number. So, name of element is oxygen, mass number is 16, atomic number is 8. You can see here is a table in which some atomic number and mass number are given. Students, follow the table which is given in your right hand side of your screen. You can see lithium, atomic number 3, mass number 7. So, how will we calculate the number of neutrons in lithium? We will subtract this 3 from 7. Result will be 4. Similarly, you can see other atoms also. Let us scroll down to the next part of table. You can see here are also some tables. Like just for example, we have aluminium. Atomic number of aluminium is 13. Mass number of aluminium is 27. So, number of neutrons in aluminium will be 27 minus 13, that is 14. Similarly, you can see we have argon. The atomic number of argon is 18, mass number is 14. Now, how will we get the number of neutrons in argon? We will subtract this 18 from this 40. The result will be 22. So, we can say there are 22 neutrons in argon. Now, students, we have seen the concept of electron, proton and neutron. Let us see one concept of isotope. Now, what is isotope? We have seen that atomic number of one element is similar. It means one element will have only one atomic number. But the same element can have more than one mass number. It means there are some elements where atomic number is same but mass number is different. Let us go to the definition. Isotopes are atoms of same element with some atomic number but different mass number. Why? Because they contain different number of neutrons. For example, hydrogen has 3 isotopes. Let us see the 3 isotopes of hydrogen. You can see hydrogen isotopes protium, deuterium and tritium. All are actually hydrogen. Students, please follow them. Protium, deuterium, tritium. All are of hydrogen. Now, let us see the figure. Students, please check this right hand side. You can see P is 1, proton is 1, proton is 1. All same. Electron E is 1, E1, E1, all same. But here is the difference. N equals 0 means neutron 0, N equals 1, neutron 1, and N equals 2, that is neutron 2. So we can say there are isotopes because of number of neutrons. Similarly, you can see carbon has 3 isotopes. How? 6, 6, 6, all similar, but mass number is different, 12, 13 and 14. So we can say chlorine has 2 isotopes. You can see 17, 17, but 35 and 37. It means that we can say what is the property of isotopes. Isotopes means elements with same atomic number but different mass number. Let us see the properties of isotopes. The isotopes of an element have same chemical property because they have same atomic number. Second property, due to same atomic number, all isotopes have similar electronic configuration. Third point, isotopes differ from each other only in their physical property. Why? Because they have different number of neutrons. Physical property means density, melting point and boiling point. Let us see one point of contradiction of Dalton atomic theory. Now it is clear that Dalton atomic theory was not fully correct. Now latest researchers have provided 2 reasons to prove their point. What are the drawbacks? First drawback, atoms are not indivisible because we have seen that a smaller part of atom are electrons, protons and neutrons. They are the subatomic particles. Point number 2, every atom of an element is not identical. This was said by Dalton, but students, we have seen that there are isotopes, and isotopes of an element are not identical. They differ in the number of neutrons. Now we have seen the basic point regarding isotopes.